Hi everyone, I'm Patricia from BigSibTutors. Today I'm going to go over a problem that is part geometry, part algebra, and would be considered around 8th or ninth grade level math for either an algebra or a geometry class, where you have to use geometry concepts such as the transversal plus algebra solving skills to solve for x and y in a diagram. So the first thing you have to know in order to solve this problem is what is a transversal and what are the relationships of the angles in a transversal. So a basic diagram of a transversal usually looks like this, where you have a set of parallel lines, lines that will never touch, with a line running through them. And so a lot of students see this diagram and think that this is all that a transversal can look like. But as long as a diagram follows these rules, one set of parallel lines with a line running through it, it can be a transversal. So for example, the problem that we're working on today, if I rotate this way, it kind of matches here. The parallel lines are diagonal and the line running through is more horizontal. It doesn't have to look exactly like this to still have the rules of a transversal, which I will get into. So the main rules of a transversal is that in any transversal, you only have two angles. You have, I like to say you have a big angle, which actually I'll indicate using green, and a small angle. And these two angles add up to 180 degrees. So anytime you have any transversal, you can automatically figure out which four are the big angle, the green angle, which are the obtuse angle, another word for big, by simply looking at the diagram or by using geometry rules such as vertical angles, angles that are across from each other, are congruent, or sometimes I like to just look at the diagram and add them in. So these are the four obtuse angles, and then these four are the four acute angles. So when you're given a question where you have to, use algebra, you basically can look and say, okay, what angles am I given in this diagram? And how do I use the fact that your obtuse plus your acute are going to add up to 180? So in this case, right, this is the obtuse angle, which means so is this, which means so is this, which means so is this. Angles greater than 90, which means that these ones are acute. So what you can do with this information is the acute plus the obtuse equals 180. So that means that these two angles add up to 180 because you see how one is green and one is red. One is acute, one is obtuse. So these would add up to 180. So you can change this geometry problem into an algebra problem by saying 7x minus 19 plus 3x plus 14 equals 180. And this is all predicated on the concept of supplementary angles, which is if you have two angles that are next to each other and they make up a line, they equal 180. So supplementary angles equal 180 degrees. And so in a transversal, your big angle and your small angle are always going to be supplementary to each other. And so therefore, they're going to add up to 180. Once you write your equation, that's when you have it become an algebra problem. So now for algebra, when you're solving for x in an algebra, your first step, if there's no parentheses, is to combine like terms. So you take the terms that have x and you add them together. So here I see that we have 7x and 3x. So together, those make up 10x. And you also have negative 19 and 14. So negative 19 plus 14, you actually subtract those absolute values. So you have 19 minus 14 is 5. And you take the sign of the larger number, which is 19. So it will become a negative 5 equals 180. So now that you combine like terms, you move on to inverse operations, which basically means to isolate x to get x by itself, you have to use inverse operation. So if you have a subtraction, the inverse of subtraction is addition. So here you have a subtraction minus 5. We're going to add 5. Negative 5 plus 5 cancels out. And 180 plus 5 equals 185. And so the reason we did that is because we're trying to get x by itself, and we've just eliminated something that's on the same side as x. So now we have to eliminate the 10. The relationship between the 10 and x is multiplication, and the inverse of multiplication is division. So we're going to divide both sides by 10, which allows this to cross out, and 185 divided by 10 is 18.5. So we've solved for x. Now we have to solve for y. So what we have to do to solve for y is, again, look at our relationships in the geometry. So you can see that the angle that has y in it is one of those green obtuse angles. All 4 of these green obtuse angles are congruent. That's one of the rules of a transversal. You have 2 angles, an obtuse and an acute. These are all congruent. So that means that 5y minus 2 must equal 7x minus 19. So 5y minus 2 equals 7x minus 19. We just solved for x, so we can substitute that in. So I'm going to put 7 times 18.5 into a calculator just to save some time. You're going to get 129.5. So we've got 5y minus 2 equals 129.5 minus 19. 129.5 minus 19 is 110.5. And then we have 5y minus 2 equals 110.5. And I'm going to add 2 to both sides, again, using that inverse operations principle. I'll get 112.5, cancel out this side. Then divide by 5, again, inverse operations. And 112.5 divided by 5 is 22.5. So the answer to this problem is x equals 18.5 and y equals 22.5. And just like all geometry problems, your key point here is to understand a geometry concept and convert the geometry into an algebra problem. So the geometry concept you had to understand was transversals, the fact that they have 2 angles, obtuse angle and an acute angle, and that you can use that information to set up equations, either by saying 2 things are congruent, equal to each other, or that 2 things add up to 180. And then you turn that into an algebra problem, which then you have to use the principle of solving to get the answer to solve. So hopefully this was helpful. Have a great day.